So we're going to program a Galt G200 series drive. The particular drive that we have here is rated 480 volt three-phase input, 480 volt output, and 5.5 amperes. When you first energize the drive, you see the set speed of the drive. The drive isn't running yet, but it's going to run at 50 hertz if we press the run push button. We have the input wired to 480 volts. We do not have a motor wired to this. Most variable frequency drives you can run without the motor in order to test them and make sure that they're operating correctly. So let's start. The first thing we're going to do is press the program button. Now when we set the program button, you can see we get a programming group. This is programming group 0. All the parameters in this drive are arranged by group. So this is programming group 0. If we hit data, then we are in programming group 0, parameter 0. And parameter 0 tells us what kind of drive we want this to be. This comes default as an open loop flux vector drive. Now that's something we're going to want to change because open loop flux vector drive, while being a very high performance method of controlling a motor, requires that you go in and carefully tune the motor. And the danger here is that at some point down the road, somebody's going to come on and change the motor. Maybe the motor fails, they replace the motor, and then you're running on a motor that was not tuned correctly. So if you want that extra bit of high performance, then you're going to need to tune the motor, and we would recommend putting some kind of a sign on there stating that whenever the motor is modified in any way, you have to retune it. So I recommend going to 2. So we are going to push data, and it's set for 1, and we will change that to 2. 2 is the space vector standard PWM mode. It will run with pretty much any motor. 99% of applications will use this mode and run just fine, and then you don't have to worry about the fine tuning of the motor, and it'll be very, very stable. So we recommend going to this unless you need just the utmost performance and speed and torque accuracy. I will hit the data enter button. In this case, it's functioning as an enter button, and now it enters that and immediately goes to programming group 0, parameter 1. Now parameter 1 is the run command. It says, how are you going to tell me to run? If you set this for 0, then it will run on the keypad. If you set it for 1, then it's going to run off the terminals that we showed you that will use a push button or a switch. So if you want to switch to turn and cause it to run, and turn the other way, cause it to stop, then you're going to want to put it in terminal mode. And finally, you can run this thing all on communication. So for now, we're going to run it in the keypad mode. So I'm going to press data, and it's set for 0, which is the keypad mode, so we're good there. Now it goes up to parameter 3. Parameter 3 is your maximum frequency, but this is also the base frequency of your drive. So I push the data button, and it is set for 60 hertz. That's good. That's a pretty standard frequency, especially in America. I push one more time, and it goes to parameter 4, and parameter 4 is the maximum frequency. Even though your base frequency might be 60 hertz, you may not want to run above 55 or so. This has to be lower than or equal to the previous parameter, the base frequency. In this case, it's 50 hertz, but I think I want to change this to 60 hertz so it can run all the way to 60 hertz. In this case, I'm going to press the shift key, and that comes over to the 5. I press up one time, and now it is 60 hertz. I will press the enter key, and now we have changed that to 60 hertz. Parameter 5 is your lower limit frequency. That is programmed for 0, and we will leave that there for now. But in most cases, we would like to program that for 12 hertz or higher, and generally it's a good idea not to run below 12 hertz unless you're sure that the motor's okay running below 12 hertz. If you have a pump or something, you may want to make sure that that pump always runs fast enough so that it does not get deadheaded. In fact, actually, why don't we go ahead and change this to 12 hertz. So I'm going to move that over, change that to a 1, press shift, change that to a 2, and now it's programmed for a minimum frequency of 12 hertz. Next is parameter 6. Parameter 6 is your A frequency reference. Now we will talk about this more in a minute, but your A frequency reference, if it's 0, it will give your frequency command or your speed command from the keypad. If you set it for 1, it comes from analog input number 1. Now on the Galt G200 series drive, this potentiometer here that's built into the drive is analog input 1. So if you want to control the speed from the keypad, it will be these up and down arrows, and that will be keypad. If you want to control it from this potentiometer, then you're going to want that to set that for 1, meaning analog input 1. If you'd like to control it from an external potentiometer or from some kind of external voltage or current reference, then you're going to want to set this to analog input 2 and wire that speed reference into analog input 2. So in this case, let's go back here. We are parameter group 0 and parameter 6. We hit data, and that's programmed for 0, which is the keypad, so that's good. We'll go ahead and leave it there. Now the next one is parameter 7 in parameter group 0. This is your B reference. So you actually have an A reference and a B reference, and we'll talk about why that's important. This B reference is the same as before. 0 is keypad, 1 is analog input 1, which is this potentiometer, and 2 is your analog input. Next is parameter 9. So let's go up to parameter 9. Now parameter 9 is the one that tells you whether you want to use your A speed command or your B speed command. So if you have A set up as the keypad and B set up as the analog input 1 potentiometer, this will tell you which one of those two to use. So here we are. We will set that, and that is set at 0. And 0 means that we are going to use the A speed command, which, as we programmed earlier, will be the keypad. Next, let's go up to parameter 11. So we'll go to parameter group 0, parameter 11, and this is your acceleration time. So this is the number of seconds to go from 0 to full speed. It's now set for 10 seconds. Let's go ahead and make that 12 seconds. So I will just push shift until I get to the right digit here, and then I'll change that to 12 seconds, and we'll go ahead and enter that. Then we go to parameter 12. Parameter 12 is your deceleration time, the amount of time from rated speed back to 0, and that is set for 10 seconds. So we'll leave that at 10 seconds. In general, you don't want to set that lower than what it would take the motor to coast to a stop. If the motor ever overhauls and tries to go faster than the drive is telling it to go because the drive is decelerating too fast, it can push power back into the drive, and you will get a DC bus overvoltage trip. So if you have an overvoltage trip, it's likely that you have a too short deceleration time, and you'll want to go ahead and lengthen that. Now next comes parameter 13. That's your running direction. So you can specify whether that runs in forward or whether it runs in reverse. And on this drive, you can specify whether you want the reverse locked out. Sometimes it's very dangerous to run something in reverse, or some damage could occur, so you can actually lock it out to make sure that no one can run it in reverse. Next is our carrier frequency. That's parameter 14. This is the number of pulses going out to the motor. And the more pulses, the hotter your drive is going to run. So we generally think you should run this around 2, 3, 4 kilohertz. If your motor is 75 horsepower and above, we recommend keeping it down around 2 kilohertz. Let's go ahead and check this. Right now it's set for 8 kilohertz. I'm going to bring that down. So let's press shift, and let's bring that down to about 2 kilohertz. And when we press the enter button, then we've set that for 2 kilohertz. Okay, next we are going to go to parameter 17. So I'm going to go up to parameter 17, and we'll go ahead and hit data enter. That is set for 0 right now. 0 is constant torque, 1 is variable torque. So if you set it for 0, that's going to work very well with elevators and conveyors and things that need a lot of torque to get started. If you have a fan or a pump, generally it doesn't take a lot of torque to get those started. And so if you'd like the pump to run a little bit cooler, if you'd like it to have a little bit less vibration and use a little bit less energy, you can set this to variable torque mode. And if you want to set it to variable torque mode, then you would change this to a 1. Now, you can run any load in constant torque load, but variable torque load will help the motor have a little bit less vibration and noise. However, if you try to run a constant torque load, such as a conveyor or elevator in variable torque, it's just going to stall because it doesn't have enough torque. So I'm actually going to change that to a 0 for constant torque, and we'll enter that. All right, we're moving right along. Now I'm going to press Program, and it goes back to my program group, and I'm going to go to Program Group 2. Then I'll hit Data, and it starts out Program 2, and we'll go to parameter 1. Now parameter 1 tells you the kilowatts. The kilowatts is going to be 3/4 of the motor horsepower. So if you have a 10 horsepower motor, you want to put in 7.5. If you have a 100 horsepower motor, it would be 75. If you have a 50 horsepower motor, it would be 37.5 kilowatts. Then we go to the next one, which is parameter 2 is your rated frequency, parameter 3 is your rated speed, parameter 4 is your rated voltage, and parameter 5 is your rated current. All of these things just come right off the motor nameplate. So just get your motor, look on the nameplate, and set these at the same values as on the motor nameplate. Now let's go back to program group 4. We will hit the program, it goes back to program group 2, and we'll go to program group 4 and enter there. And we want parameter 0 in parameter group 4. This fine-tunes your volts per hertz settings, or in other words, the constant torque versus variable torque. And this only works when you are in standard PWM mode. So if this is set for 0, that's constant torque. If it's set for 4, it's variable torque. If you set it for 2 or 3, that will give you something between constant torque and variable torque. So you might want to set it for a 3 that gives you a variable torque setting, but gives you just a little bit of extra torque in order to aid in acceleration. And we've got one more to set now. We will hit Program to go back to Program Group. Then we'll go up to Program Group 5. And we will enter Program Group 5. In Program Group 5, we're going to parameter 1 in Program Group 5, and that is set for a value of 1. Now this is for your external start signal. If you're going to run off the keypad, you don't need to set this at all. But if you're going to want to start it from somewhere else, setting this to 1 will cause your S1 terminal to start the drive and run it in a forward direction. If you set it for 2, it will start it in a reverse direction. So if you're going to use a start switch in order to start and stop this thing, wire the switch to the S1 terminal and then go ahead and program this in general for a value of 1 so that when you turn that, it's going to start and stop in the forward direction. All right, we're pretty much done. There are a lot of parameters in here. It's a very sophisticated drive, but what we've shown you is the basic parameters that should allow you to program and start and run most applications. Now I'm going to hit Program. It goes back to Program Group 5, number 1. Hit it again, it goes back to Program Group 5, and one more time, and it goes back to our frequency. Now all I need to do is hit Run, and when I run, I can see it will begin ramping up. We have it set to accelerate in 12 seconds, and so it will go from 0 to 60 Hertz in 12 seconds. In this case, it's only going to 50 Hertz because that's where we had the frequency set. If I want it to go higher, I just push this up button, and you can see that that will increase my frequency setting. So I can set that for 60 Hertz now, and the drive will ramp to 60 Hertz. If I de-energize the drive, turn it back on, it will remember that it was running at 60 Hertz last time we started it, and that will be our speed reference. So again, that comes off these up and down buttons. If I want to use this potentiometer to control that, I'm going to go back and I'm going to set my frequency command A to 1 for analog input 1, which is my speed command. If I want to stop, I simply push stop and it begins to stop. If your motor is running in the wrong direction, you can have this go in reverse, but it generally makes more sense, so it doesn't confuse people, to switch any two of the motor leads. There's 3 motor leads. Switch any two either at the drive or in the motor conduit box, and then the motor will go in the correct direction if it was going in the wrong direction. So that's the basic programming of the Galt G200 series drive.